If you've done any code editing, then you know that properly closing your brackets can be quite frustrating. So how does your text editor know that this is valid? So what defines valid parentheses here? Well, for every open bracket, there needs to be a corresponding closing bracket. But additionally, inside any other pair of brackets, every other pair of brackets also needs to be properly opened and closed. So you can see these two here are properly open and closed because there's corresponding brackets. And then you can see this green one is also properly open and closed. In addition, outside of these green ones, these two orange brackets are properly open and closed because they have a pair, and then everything inside of them is also properly open and closed, which means all of this is properly open and closed, and then these are properly open and closed. It's a bit complicated to explain it, but pretty much everyone can understand it intuitively. In addition to this, we would like to introduce 3 different types of brackets. So if we were to change, for example, these two green brackets to, let's say, these curly braces, then this would still be valid. But if we were to change this orange one here to, say, a square bracket, then this would be no longer valid, because even though that this has this as a partner, they are different. They don't correspond, so this is no longer valid. So let's take a look at some more examples. Are these all valid? Well, this one is valid because you can see we have this pair here, then this square bracket corresponds to this one, this curly bracket to this one, this circular one to this one, and this square one to this one. So this example is valid. This one is also valid because it's pretty easy to see that we have one open and closed pair here, one here, one here, and one here, so this one is also valid. This one is pretty obviously invalid because you can see that we only have one closing bracket, but we have all of these opening brackets, so this isn't valid. Now this one's a bit more complicated, but we can slowly work it out. We can see that this is obviously valid, and then these two curly brackets enclose this circular bracket, so that's valid. This is valid because it's a pair by itself, and then you can see it's a lot more easier. This one corresponds to this one, and then this one corresponds to this one, so this is valid. So if you've been following along, we've actually already come up with how to solve this. If you take a look at these two valid expressions, you can see that if we actually just concatenate them together like this, it's still a valid set of parentheses. So this valid expression here is actually now just made up of 2 valid expressions put together. And then additionally, inside any valid expression must also be a valid expression like this example here. And then the same is also true inside of that. This entire expression must be valid. And at that point, now you can see that this is a valid expression because it's 2 valid expressions put together like this. And if you remember what we said was a valid expression, it's any time that a open bracket is properly closed with a closed bracket. So the expression is valid if for the opening bracket we find a corresponding closed bracket and any expression we found inside was valid. That means the corresponding bracket to the first bracket in must be the last bracket out. Everything else inside must be closed first, or it's invalid. So we can compute this with a stack. So our algorithm is going to look like this. We're going to evaluate the expression left to right with a pointer. If it's an open bracket, then we're going to put it in the stack like we said before. So let's do this. We look at this one and we see that's an open bracket, so that goes into the stack. Then we move. We see that this is an open bracket, so this goes into the stack. Then we move. We see that this is an open bracket, so this goes into the stack, and we move. Well, now we've seen a closing bracket. So what do? Well, if the top of the stack is the correct closing bracket to this one, then that means that we can just pop the stack because we found a correct pair. So we'll do just that. We move right and see that this is another opening bracket, so we put it on the stack. And then we see that this is another closing bracket, and this is the correct corresponding bracket to this one, so that means that we can just pop the stack and keep going. This is another closing bracket, and it's the correct closing bracket to the top of the stack, so we can just pop that. This is another closing bracket, and it's the correct closing bracket to the top of the stack, so we can just pop it again. Now, before we move on, what if we were to encounter another closing bracket like this? Well, we would see that there's nothing in the stack. That means we have a closing bracket with no corresponding opening bracket. In that case, then the expression cannot be valid, and we need to return false. But in any other case, we just keep going. We see that this is an opening bracket, so we put it on the stack. We see that this is a closing bracket, and it's the correct corresponding corresponding closing bracket to the top of the stack, so we pop, we see that this is an opening bracket and we put it on the stack, and we see that this is the corresponding closing bracket, so we can go ahead and pop the stack. So now we've evaluated the expression, so what do? Well, if the stack is empty, then we've evaluated everything. In that case, the expression must have been true. But if there were something left on the stack, let's say this curly brace, then that means that there was an opening bracket with no corresponding closing bracket. In that case, we have to return false. In our case, there wasn't, which means we return true. So let's go ahead and code this up. So the first thing we're going to need is the stack. That's the most important part of this solution. So let's make a stack of characters. Now it'll be useful if we have a way to map each brace to the correct corresponding closing or opening brace. So let's go ahead and make a hash map or an unordered map of characters to characters in order to do that. So let's map the closing bracket for a curly brace to the, well, opening bracket to a curly brace. And let's copy that 3 times for ease. The closing bracket for a parentheses goes to the opening bracket for a parentheses. And the closing bracket for a square bracket goes to the opening bracket for a square bracket. Now let's go through each character in our expression. For every character C in the string, in the input string S, if we have an opening bracket, so if it's equal to this, or this, or this, then what do? We push it onto the stack because it's an opening brace. So if it's not an opening bracket, then it must be a closed bracket. So what do? Well, first we have to see if we have an invalid expression. So if the stack is empty, then it's invalid. But it's also invalid if the top of the stack is not the correct corresponding opening bracket. So if the opening bracket that the closing bracket we just saw does not map to what's on the top of the stack, then that means we have to return false as well. So if the stack is empty or it's the wrong corresponding brace, then return false. Otherwise, we can just pop the top of the stack. So what do if we've made it through the entire thing? Well, if it's empty, we return true, otherwise false. So that means we can just say return whether or not the stack is empty. So let's go ahead and see if this works. And it does, beating 100% of submissions.